Okay, guys, so we are moving on to our third and final type of chi-square test. I know there's a lot of reading in this top paragraph, and so I'm just going to paraphrase or summarize. This third type is called the chi-square test for independence. Remember in the past when we've talked about independence, we were talking about two variables and checking to see if they are independent from each other, from each other. This is the exact same thing. So in a chi-square test for independence, we are utilizing a two-way table again, but the biggest difference between this one and our test for homogeneity is that we have one population and multiple variables for that one population. And that's because we're checking to see, are those multiple variables independent or dependent? And so in our chi-square test for independence, the null hypothesis states that there is no association between the categorical variables being studied, whatever they are. And then the alternate would say that there is an association or they are dependent. So if there is no association, they're independent. If there is, they are dependent. Now, the benefit of the two-way table, similarity is that these tests run identically to how they did with homogeneity with our last section. And so this is going to feel familiar. This is going to seem like old hat to us. And so here's our first example. It says a study followed a random sample of 8,474 people with normal blood pressure for about 4 years. All of the individuals were free of heart disease at the beginning of the study. Each person took the Spielberger Trait Anger Scale test, which measures how prone a person is to sudden anger. Researchers also recorded whether each individual developed coronary heart disease, and this includes people who had heart attacks and those who needed medical treatment for heart disease. So here we have a two-way table. We've got coronary heart disease and their anger levels. Those are our two variables for this one population that had normal blood pressure. All right. Our null hypothesis will say anger level and coronary heart disease are independent. And our alternate will say that they are dependent. Anger level and coronary heart disease. Okay. All right, here's another one. Statisticians investigated the relationship between gender and having allergies for a random sample of 40 students who completed a census at school survey. Here's a two-way table that summarizes the data. So here we've got their gender and whether or not they have allergies. So our null would say gender and allergies are independent. Our alternate will say they are dependent. Maybe it's faster if I just write it. Okay, moving on. Finding those expected counts is identical to homogeneity because we still have a two-way table. So we do this guy, row total times column total divided by table total. We have three conditions. The third one is independent, which we know. All three of them, random, large counts, independent, easy peasy. And then to calculate our test statistic, we use our same old formula from our formula sheet, the one we have used this whole time. All right, then finding that p-value is identical as well. So we use chi-squared CDF, where we go from your test statistic to 1,000 or 10,000. And then our degrees of freedom are equal to the number of rows minus 1 times the number of columns minus 1. All right, so here's the data we had from example 1. We are going to first find the expected counts. And so maybe in this case, we'll just redraw this. So we'll have coronary heart disease, no coronary heart disease, total. And then we'll have low anger, moderate anger, and high anger. Their total there. Okay, so remember our totals all stay the same. 4, 7, 31, 6, 33, so 84, 74, 190, and 82, 84. So now we calculate. So if I do 190 times 3110 divided by table total 80, I get here 33.03. We know that must add up to 3,110, so I'll do 3,110 minus that to get 3,076.97. Okay. Then if I do 190 times 4731 divided by 8474, I get 106.08. Now 4731 minus 106.08 is 4624.92. And then 190 times 633 divided by 8474 is 14.19. We get 618.81. All right, so now check the 2 conditions, 3 conditions. So random, they did take a random sample, yes. Large counts. We can check that off because all expected counts are greater than or equal to 5, and then independent trials or trials, because 8,474 is less than 10% of all people with low blood pressure. All right, so now our test statistic, I'm going to zoom out so that I can see all my numbers. So chi-squared will be equal to 53 minus 33.03 squared over 33.03. 110 minus 106.08 squared over 106.08. And 27 minus 14.19 squared. Then our second row is 3057 minus 3097. Um, 4621 minus 4624.92. Oh, I'll just squeeze it in. And then 606, 618.81. Okay, so now we calculate. I hope my handwriting is not atrocious for you. So 53 minus 3.0. Okay, so I am getting a chi-square value here of 24.18. That's pretty large, but we have a few places where our numbers are far apart. So it kind of makes sense. So now our p-value, we'll say chi-squared CDF from 24.18 to 1,000 with, let's see here. So we had number of rows, 1, 2 minus 1 times the number of columns, 1, 2, 3 minus 1, so that's 3. Oh no, equals 2. What am I thinking? Okay, this is a scientific notation number. Remember, 5.61 times 10 to the negative 6 would be 5 zeros. 5, 6. And there we go. All right, so that is a test for independence. Probably, well, definitely, this would allow us to reject the null in favor of the alternate and therefore say that the level of anger you have does depend on whether or not you have coronary heart disease, or vice versa, that if you have coronary heart disease, that might change the probability that you have high, moderate, or low anger. All right, so you have an exit ticket here to do today, and hope it goes well.